Hello, welcome to Module 6, an Introduction to Loops. So what are loops? Loops are used in programs when you need to repeat things. So if you wanted to do something more than once, right now in our programs we can just basically execute something and finish it. And then if you wanted to do it again, you'd have to re-execute your program, which doesn't make much sense because most interactive programs you want to do some things more than once. So a loop allows you to repeat things. So if you take a look at this flow chart right here, if you need to have any steps repeated, then of course, if you do not, then you don't need a loop. But if you do need to have steps repeated, then you need to use a loop. So there are different types of loops that are available for use. And the ones that we will focus on are sentinel controlled loops, input validation loops, general condition loops, and the easiest loop to do is a counting loop. A counting loop is used because if you know how many times the loop is going to go, you would use a counting loop. Then you'd say, okay, I want to add up the first 10 numbers 1 through 10. So you would know that that loop would go 10 times. That's why a counting loop is different than one of these kind of loops in which you don't know how many times it's going to go, because you might say, have the user continue to play a game until they enter Q to quit. So that would be a loop that you don't know how many times they're going to play the game until they enter the queue to quit. Or another example could be you're going to continue to get input until the user enters some kind of sentinel value or a -1 to stop entering input. So the loop body, so the way that loops are structured, there's 3 different types of loops. And so in the next slide, I will go over the different types of loops. So the 3 different types of loops are, there's a for loop, and a while loop, and a do while loop. So if you're using a for loop or a while loop, there are 3 things that you need to take into consideration. The first thing you need to take into consideration is initialization. So after you decided that your program is going to require a loop because you want to repeat something, you're going to have to then decide what your loop controller is going to be. How is it going to be controlled? So if it's a counting loop, it's pretty easy. You'll have a counter or an iterator that's going to count how many times something runs. If it's a loop that's going to end with the user entering a queue to quit, then you have a character that is controlling that. And if it's a loop that you're going to have the user continue to enter numbers until they enter a -1, then you would have an integer to control that. So it's very important that you first figure out what it is you're trying to do with your loop, and then you'd need to figure out how you're going to control your loop. So for for loops and while loops, you need to do these 3 things. Number 1, you need to initialize your loop controller. Then you need to do test. You need to see if the condition is true or false. Now the way tests are done for for loops and while loops are very similar to conditions. You just use an expression, and in that expression, you test your loop controller against some kind of value that would make your loop stop. And we're going to develop loops, and everything will be much more clear as we start to create loops. This is just an overview. The third thing you need to do is update. An update step for loops is very important because if you don't update, you could end up with an infinite loop. What is an infinite loop? An infinite loop would be a loop that never stops. It just continues to go and go and go and go and go because the test condition continues to be true forever and ever and ever. The test condition is true, so therefore you need to make sure that you do the update step. So again, these are only 3 things to remember for for loops and while loops. Do while loops are a little bit different because of the way that they're structured. So initialization is not always important, but of course, step 2, test, and update are very important. So we're going to start first with for and while loops, and then move on to do while loops. All right, so for different kinds of loops, this just is giving you an overview of what kinds of loops would be best for different types of situations. So counting loops, you can use anything that you can do with a for loop, you can do with a while loop. So a counting loop is you can do with a for or a while loop. In sentinel controlled loops, I would suggest that a while loop would be better, just by the structure and the way it works. End of file loops, I would also suggest a while loop for that. Input validation, this is a loop in which you repeat by interaction. Now sometimes you might want to use a while loop for this. If you're going to be sure that it's going to at least run one time, like a game or something, usually if you log on to a game, you play a round of the game and then you decide if you want to go again. So that would be a do while. And other conditional loops, you can use, again, anything you can do with a for loop, you can do with a while loop. All right, so a counter. This is a counter controlled loop that's going to count how many times a loop goes. So say, for example, you wanted to have a loop that's going to run 10 times. All right, so the different ways in which you would do this with a for loop versus a while loop are as follows. So say, for example, you wanted to print something onto the screen 10 times. You wanted to print programming is fun 10 times. So I want to print programming is fun 10 times. So I already know that I want it to print 10 times. So I have to use a variable that's going to make sure that my loop is going to run 10 times. So I'm going to use a variable called I. So over here, I'm going to do a for loop. I'm going to declare a variable called I. And for my while loop over here, I'm going to declare a variable called K. So I'm going to show you how to make a loop go 10 times with a for loop and a loop to go 10 times with a while loop. So the way a for loop works is, remember I said before you have initialization, number one, you have test, and you have update. So the way a for loop is structured is and everything in C, just like with conditions and functions, and everything is done using blocks of code. So in a for loop, you use a keyword for, and you have parentheses, and then it's a block of code. So inside the parentheses of a for loop, by the structure of it, you put the initialization step in the beginning. So I'm going to start when I is equal to 0. I'm initializing my counter to 0. Then the second part of the for loop has the test condition, I less than 10. So if you think about that, if I initialized I to 0 and the test is less than 10, then it's going to go 10 times. It's going to go when I is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when I becomes 10, this test will become false. And then the third part, these are separated by semicolons, is how I would like to iterate my I. So if I wanted to go 10 times and my condition starts from 0 to 9, then I want it to go up by 1 each time. So I would say I equals I plus 1. So that's all I'm doing right here. This right here is a loop that's going to go 10 times. And what it's going to do is, if this test condition right here is true, it's going to go inside of the loop body and do whatever is in there. In this case, printf programming is fun. All right, so let's just see how this works. So when this for loop would be somewhere inside of a function. It could be inside your main function, or it could be inside of another function. So as soon as the code hits this for loop right here, it's going to do the initialization. It only does it the first time it hits the for loops, and it does it once. So it will initialize I to 0. And then it will do the test. It'll say, is 0 less than 10? Yes, that's true. That condition is true. So it will go into the function body and do the instruction. Then after, it will do the update step. I equals I plus 1. So if I was 0, now I is 1. After it does the update, it will test. Is 1 less than 10? Yes, it is. It'll go into the loop body. Then it will change it to 2. Is 2 less than 10? Yes, it is. So it will continue to do this until eventually this test condition right here becomes false. So when eventually this becomes 10, it'll check, is 10 less than 10? And that will become false, and it will no longer go in the loop body, and it will continue to do whatever instructions are down here below. Now let's see how to do the same thing with a while loop. A while loop works a little bit differently because a while loop uses a keyword while, but the only thing that you put in the parentheses or the header of the while loop is the test condition. So we're going to do the same loop, but we're going to notice that the initialization of k equals 0 must go before the loop. This is initialization. The test goes in the loop body. That's k less than 10. And then we can put our printf statement here. And then we can have our update. It's very common to forget the update step in a while loop because it's not set up to remind you to put all of the steps inside of the header. So again, the way that the while loop would work would be that it would initialize here. This is the initialize step. Then it would test, is k less than 10. Then it would print programming is fun. Then it would update. So k started out as 0 and now k is 1. Is 1 less than 10? Yes, it is. Programming is fun. 2. Is 2 less than 10? Yes, it is. Until eventually k would become 10, and then 10 is not less than 10, and this condition would become false, and then it would end the loop and continue down here after the loop body. All right, so here's a couple examples. This is another counter-controlled while loop example, and you can see here that it initializes a count of employees to 0. It checks if the count of employees is less than 7, and then it will do all of these things, and then it will increment count employees by 1. So if it started out as 0, it would then become 1, and then it would check is 1 less than 7. So again, this is just another example, just showing you that you can do other things rather than just printf a statement. You can do a whole bunch of instructions inside of your loop body block of code, but eventually you need to have an update step, which this right here is the update. So the count employees equals 0 is initialization, count employees less than 7 is the test condition, and count employees equals count employees but plus 1 is the update step. All right, so this is just it shows you that if it is true, this is just a flowchart that it comes in. If it's true, it will go into the loop body and do that, eventually increasing the count by 1, then testing to see if it has reached the point in which 7 is less than 7, which makes it false and makes the loop stop. And it's very important that you remember in while loops that you need to put the update inside of the loop body. All right, so here's the thing about compound assignment operators. So if you can notice here that you can shorten up your assignment statements. So here we have count emp equals count emp plus 1 can be shortened by using this compound assignment operator of plus equals. Or you can use it for minus equals, or you can use it for times equals. So all that is showing here is that you could take a number, if you have a number, and if you're increasing that number, so number equals num plus 4, for example. This is just another example. Instead of writing out a long sentence like that, it can be reduced to say num plus equals 4. And both of these two do the exact same thing. Now, if you wanted to increase something by 1, like count equals count plus 1, this only works if you're going up by 1. it can be changed to count plus equals 1, or it can be changed to count plus plus. You can do the same thing with subtraction. You could do count equals count minus 1, could be count minus equals 1, or count minus minus. But if you're going up by 4, you can't do count plus 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 plus. You have to say num plus equals 4. All right, so here's another example of just the difference between a for loop and a while loop, like I wrote out in the earlier slide. In the for loop, you use the for loop to have your initialization, your loop repetition, or your update. This is the test condition, sorry. Your test. So you have your initialization, your test, and your update are all part of the header of the for loop, and then the loop body. And the only way you go into the loop body is if the test is true, right? A while loop just has the initialization before the loop body. It has the test is the only thing that goes in the inside of the header of the while loop, just like a condition, like an if condition, but this is a while. An if condition, the difference between a while loop and an if condition is a if condition will only go one time. A while loop will continue as long as this is true. It will continue to go inside of the loop body and do whatever inside. So it's important to remember that the update for the while loop is inside of the loop body. And most of you will probably write some infinite loops as you're learning how to write loops. All right, so here is, so I'm going to stop right here because, and start again on another video.